With Gaia's heart beating once a year, and figuring that a Gaian minute lasts for an entire 80-year human lifespan, then to Gaia, 1 year is equivalent to 42 million of our human years. As we've seen, the last Gaian month, consisting of 3.5 million human years, covers both the current Holocene epoch as well as the previous Pleistocene epoch, which together are referred to as the Quaternary period. The earlier Pliocene epoch and prior to that Miocene epoch constitute the Neogene period, which started about 6.5 months ago. Going back even further, the Oligocene, Eocene, and Paleocene epochs form the preceding Paleogene period, which started almost 19 months ago. This last year and a half or so, consisting of these 3 geologic periods subdivided into 7 geologic epochs, is also referred to as the Cenozoic era, as opposed to the preceding Mesozoic era that ended with the Cretaceous period. Toward the end of the Cretaceous, just under 2 Gaian years ago, is our best guess for the origin of primates based on genetic studies. These early primates would have been small, nocturnal, insectivorous tree dwellers. By the time the Cretaceous ended, they had diverged into the 2 main branches we still see represented in modern primates. On one side, the strepsirrhines, which today include the lemurs, galagos, and lorises, and on the other side, our own ancestral lineage of haplorhines, today comprising monkeys, apes, and probably tarsiers as well. The Cenozoic era started in a rather dramatic fashion, with the extinction event, likely caused by an asteroid impact, that killed off the non-avian dinosaurs and left many evolutionary niches open for mammals to diversify into and fill. For this reason, the Cenozoic era is also poetically known as the Age of Mammals. The Paleocene epoch in particular, covering the first 3 months or so of the Cenozoic, saw an explosion of mammal and bird diversity in the aftermath of the extinction event. For instance, this is when those various forms of early primates first start showing up in the fossil record. By once again looking at the isotope record of deep-sea sediment cores, we can see that, in general, the climate of the Paleocene was around 10 degrees Celsius warmer than today, a tropical environment that covered most of the globe and kept even the poles ice-free. Around 16 Gaian months ago, the temperature spiked suddenly, in an event known as the Paleocene-Eocene Thermal Maximum. Likely triggered by a massive amount of carbon released into the atmosphere due to volcanic activity, the global temperature increased another 6 degrees Celsius or so over the course of tens of thousands of years, to Gaia just the space of a few hours. After reaching a peak in the early Eocene, the climate began to cool throughout the second half of the epoch, with Antarctica just beginning to ice over around 13 Gaian months ago. Also, at some point in the mid-Eocene, our haplorhine primate ancestors split into the New World monkeys, who colonized South America from Africa either by island hopping or by being swept across the Atlantic in a serendipitous raft, and the ancestors of apes and Old World monkeys, whose lineage stayed in Asia and Africa. There was a brief interruption in the Eocene's overall cooling trend at around 1 Gaian year ago, possibly related to the collision of the Indian subcontinent with Asia around this time, forming the Himalayas and releasing a large amount of carbon dioxide in the process. Pretty soon, though, the planet was cooling again, a process which accelerated dramatically around 9.5 Gaian months ago at the Eocene-Oligocene boundary, when South America and Australia had drifted far enough away to completely isolate Antarctica behind the Antarctic Circumpolar Current. This resulted in the rapid glaciation of Antarctica, changed ocean circulation patterns, and, along with a drop in atmospheric carbon dioxide, caused further global cooling. These sudden changes are associated with another minor extinction event, though nowhere near as bad as the one at the Cretaceous-Paleogene boundary. The early Oligocene, around 9 Gaian months ago, is also when the ape lineage diverged from the lineage leading to the so-called Old World monkeys, including baboons, colubuses, and macaques. Of course, this means that Old World monkeys are actually more closely related to apes, including us humans, than they are to the New World monkeys. So the term monkey by itself is a bit ambiguous, since these two separate groups have distinct origins in the primate family tree. The climate stayed relatively stable over the course of the Oligocene, and even saw some regional warming toward the end of the epoch, though not enough to significantly reduce the now well-established Antarctic ice sheets. By the time the Neogene period began with the start of the Miocene epoch around 6.5 Gaian months ago, Antarctica was mostly covered with ice, and would remain so until the present day, despite some fluctuations in extent. This is also roughly when the last common ancestor of all apes lived, and as we learned in the previous video, the 5 months of the Miocene were an important time for the evolution of modern ape genera in Africa and Asia, with the family tree diversifying into gibbons, orangutans, gorillas, chimpanzees, and pre-human hominins. Geologically, the continents had more or less reached their present positions by the end of the Miocene, and the climate had cooled further in the second half of the epoch. The lower sea levels, combined with a tectonic uplift, closed the Strait of Gibraltar, cutting off the Mediterranean Sea from the Atlantic and temporarily drying it out several times before the strait opened back up again at the beginning of the Pliocene. The cooling trend continued during the Pliocene, and toward the end of the epoch, around 1 Gaian month ago, Arctic sea ice began to form. By the end of the Pliocene, 3 weeks ago, we had fully transitioned into the current icehouse climate, and the subsequent Pleistocene epoch would be marked by the successive expansion and retreat of the Northern Hemisphere ice sheets, culminating in the last glacial maximum around 5 Gaian hours ago. As we've seen, this last month also encompasses the Paleolithic, when a succession of early hominins developed a variety of stone tools, control of fire, and other cultural adaptations over the course of the Pleistocene glaciations. Finally, the current Holocene epoch began just 2.5 hours ago with the most recent glacial retreat. So one lesson to take away from this history is that large-scale changes in the Earth's geography and climate generally take months to years on the Gaian timescale, with the exception of a couple instances where minor shifts or excursions from the general trend have occurred over a matter of a few Gaian hours or days, often in response to changes in atmospheric carbon dioxide. In comparison, our civilization has been pumping large quantities of anthropogenic greenhouse gases into the atmosphere only since the Industrial Revolution a couple of minutes ago. But this is already having a significant effect, so much so that we've basically canceled the next glacial period completely. At first, that may sound like a good thing, but when such climatic changes happen so fast, species that are accustomed to more stable conditions, including us humans, may not be able to adapt in time to survive, or to avoid massive suffering at the very least. While the Earth has certainly seen periods with much warmer global average temperatures in the past couple of Gaian years, there has never been a time when the temperature has changed so rapidly as it is now due to anthropogenic global warming. The global climate record of the Cenozoic shows that atmospheric carbon, for all that its concentration is measured in parts per million, is not just some inconsequential byproduct of geologic processes, but rather a powerful driver of the environmental conditions affecting all life on this planet. But all of this is still just looking at the most recent couple of years of Gaia's life, and the Earth is much older than that. In my next video exploring the Gaian timescale, I'll go all the way back to the beginning, when the Earth was formed around 108 Gaian years ago. That's 4.5 billion years to us. We'll see that life has existed on Earth for close to a Gaian century, and we'll learn just how much a planet can change in a century's worth of 80 years per minute heartbeats.